In this video, we're going to learn how to name the most basic hydrocarbons, and then there'll be a follow-up video where we name more advanced ones, several follow-up videos where we name more advanced ones, but today we're just going to focus on the easy ones. So a couple things. If there's a double or triple bond, the carbon chain must be numbered, kind of like a condensed version that I showed you before, if more than one version is possible. I'll explain what that means when we get to it. It's actually much easier to do or to see once we get to a problem that can do that. And then you number the carbon chain so that the double or triple bond is as low as possible. Again, I'm going to explain that when we get to it. So let's just start with the naming and go right into it, and then we'll come to those when we get to our second set of problems. So for naming alkanes, so these guys have all single bonds, so that should this makes the naming very easy. If your formula says there's two C's, you're going to write out your general formula, C2H6, C4H10, C5H12, C6H14, and C6H18. Now we're going to draw their structure. I'll come back to the name in a second. So we need a stable structure. So here's the easy way to do it. Since they're all single bonds, you bond your two carbons together. Here, you always start by bonding your four carbons. And this one has 8. So now we are going to add our H's. There's my 6 H's. Every carbon has 4 bonds, which is what I'm looking for. So 1, 2, 3, 4, 1, 2, 3, 4. The bond that's shared gets counted obviously towards both. So every carbon has 4 bonds. All the hydrogen have 1 carbon. I've got a stable molecule. That's how you check them. So the next one, four carbons, 10 hydrogen, all the carbons have 4 bonds, all the hydrogens have 1 bond. Again, that's how we double check. As you can see, they get larger. I want you to draw the H's every single time. I do not want to see this. While I may do this in class, you are not allowed to. Not yet. Common mistake I see a lot is I'll see students writing lowercase h's. I don't know if it's just because lowercase h is easier to write, mildly easier to write than a capital H, but don't write lowercase because element symbols are always capitalized. So if you write a lowercase h, then it does not mean hydrogen in terms of chemistry. It means something else. What it means, I don't really know, but it definitely means it's wrong. I can tell you that much. So there's your structures. Now let's name them. So the way we name them is we use table P and table Q. 2 carbons in a row, there's a prefix for that. Now normally in naming, we would use, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. We use those for naming covalent compounds. Well, here's the unfortunate part. Organic compounds get their own set of prefixes. Luckily, most of them are the same, but the first 4 are not, meaning for naming covalent, pent, hex, hept, oct, non, dec are the same, but the new ones are going to be meth, eth, prop, and bute. So you may want to write that in. For covalent molecules, we use mono, di, tri, and tetra. For organic molecules, we use meth, eth, prop, and bute. All right, so you get your prefix from here. So 2 carbons is eth. And then the ending, since it's an alkane, it gets an ane ending. So it becomes ethane. The F tells me that it's 2 carbons. The A and E tells me that it has all single bonds. For the next one, it has 4 carbons, so bute. A and E ending tells me they're all single, so butane. Maybe you've heard of it. You've probably heard of propane, which is what we burn if you have like a gas barbecue. You burn propane for that. Same, and then a lighter, like the little lighters that you use that have the liquid in it, that's a butane lighter. That's because it's burning butane. So they are around, and they are, you know, very common fuels. But let's finish the rest. So we have pentane. This one would be hexane. You can make it a capital or lowercase. I don't really care about that. And for this last one, octane. Maybe you've heard of that when you buy gasoline. If you drive a car yet, when you buy gas, there's numbers at the pump. Usually they're like 87, 89, and like 93 or something like that. If you read those little labels, like under it, it says it's the octane rating. It's how much octane. It's actually in what's called parts per million, which we'll learn about later, but it is the rating of how much of the octane is in that gasoline. The higher the octane, the more expensive, and typically the better the gas is. So, condensed formulas. So these should be pretty easy. Carbon 1 would be right here. Maybe I'll use a different color to make it stand out. So there's carbon 1, CH3, there's carbon 2, CH3. So if you notice, there's going to be a very obvious pattern here. CH3, CH2, CH2, CH3. The next one, I'm going to go a little faster. So the way I count them is I've got 1, 2, 3 carbons in the middle, so I have 3 CH2s, and then a CH3 on either end. There we go. And then the last one, I'm probably going to run off the page, so you can totally do that. That's fine. There is a faster way to do this, but again, you don't get to do it until you've graduated. This means the same thing as that. It's basically saying I just take the CH2 and repeat it 6 times in a row, and then I end with the CH3. You don't get to write that on the Regents ever. So a common question at the end is how many bonds are in a molecule of propane? So propane, if we know, propane, the prefix means 3. So the common answer that I see a lot is 3, and you get it wrong. Another common answer is to say, well, propane is C3H8. So if I just add 8 and 3 together, I'll get 11 bonds. And then you also get it wrong. The only way to really do this is to draw the propane out and then count the number of bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bonds in a molecule of propane. So be aware of that. They like to put that, I like those questions, or I should say those questions do show up a lot. It's kind of silly, but they're easy points, so that's why I like them, as long as you don't fall into the trap. And typically it'll be a multiple choice question, and you'll see like choice A will be 3, choice B will be 11, choice C will be some random number that makes no sense, and then choice D will be the actual answer, or it might be a part 2 as well, because then they could say I want to see it as well. So just be aware of that. Now let's get to the harder ones. So alkenes are where some of these rules that I skipped over, those rules that I said that we were going to skip and come in when I got to it, well, now we're here. So alkenes have those weird rules where we may have to number the carbons, and we're going to have to count the double bonds. So I'm going to end this video here and then pick up the alkene video in a separate section.